Hello everyone, welcome back to my channel. Let's do it. I am Shruti. If you like my video, please like, share and subscribe to my channel. Share to your friends, relatives, your juniors and your neighbors so that they can get maximum benefit of my video. And don't forget to press the bell icon. Today I am going to start science series, that is basics of science. So let's begin. Today's topic is metals and non-metals. Students, we see many things around us like chalk, duster, table, bench, gold, silver, sand, iron, copper, aluminium, etc. These are nothing but materials. A material could be used to make a large number of objects also. For example, using iron we can make tables, chairs, etc. It is also possible that an object could be made of a single material or of many different types of materials. For example, as I said before, using iron we can make table. So here only one material is used, that is iron. Okay, so we can say that an object could be made of a single material also. And steel is made of iron and carbon. So here two materials are used to make steel, that is iron and carbon. So we can say that many different types of materials could be made of these objects. Some materials are shiny in appearance while others are not. For example, if you take a gold and silver, diamond, etc., these appears as shiny. But so for example, chalk, duster, does it shine? No. So we can say that the materials may be of shiny in nature. Some are rough, some are smooth and some are hard and also soft. Okay. Some materials are soluble in water and some others are insoluble in water. Here what is soluble means? Here soluble means if you take a water and a spoon of sugar, and if you put a spoon of sugar in water, after some time the sugar get dissolved in the water. So this is called as solubility. Sugar is soluble in water. If you take water and oil, if you mix this, these two will not mix and the oil will not dissolve in water. This is nothing but insolubility. Okay, so here oil is insoluble in water. And also some materials are transparent, some are opaque and some are translucent. Here transparent means from one side we can see the other side also. For example, glass. From glass we can see the other side also. This is called as transparent. What does mean by opaque? Opaque means from one side we cannot see the other side. For example, wood. If you take an wood piece, can we see from one side to other side? No, we cannot see. Therefore, such materials are called as opaque materials. What does mean by translucent? Translucent means from one side we can see the other side partially but not fully. This is called as translucent. For example, paper dipped in oil. If we dip a paper in oil, from that paper we can see partially from one side to other side. This is called as translucent. Transparent means we can see from one side to other side. Opaque means we cannot see from one side to other side. Translucent means we can see partially from one side to other side. So students, let us know what is matter. Anything that occupies space and has some mass is called as matter. Let's take this box. Okay. Now this box occupies some space and also it has some mass. Therefore, it is called as a matter. Right? let us take this sketch. Sketch pen occupies space and also it has some mass, therefore it is also called as a matter. Okay, so anything that occupies space and has some mass is called as matter. Okay, what does mean by substance? Substance is nothing but a matter that has some specific composition and some chemical characteristics. As I said, this Bodmas became matter. So this matter has some specific composition and also it has some chemical properties because it is made of metals. Therefore, it has some specific composition and also it has some chemical characteristics. So now this can be a substance. Okay. Let us see changes in substances. There are two types of changes in substances. First one is a physical change and second one is a chemical change. Let us know what is physical change. Physical changes are the changes in the physical properties of the substances. So what are these physical properties? So these physical properties may be a change in shape, a change in size, a change in color, or a change in state of a substance. Let us understand this through an example. Okay, students, see here I have this piece of paper. So it has occupied space now and also it has some mass also. Therefore, this paper piece will be what? Substance. Now I am going to press this paper. So what the changes you have observed here? Yes, right. Here the shape of the paper has changed. Before that was in the rectangle shape. Now it has become like this. So this is nothing but a physical change. Okay. What about the size of this paper? Before this was in rectangle size, but now it has become somewhat like spherical shape. Okay, it is not exactly spherical, but it looks like spherical. Okay, so we can say that there is a change in size of a substance. Okay, what about the color? There is a one chemical substance named as sulfur. After dissolving that sulfur, the color will change. That is an example of physical process. Let us see an example state of a substance. Suppose consider a ice cube. After some time, the ice cube will melt. Before it was in the which state? Solid state. After some time, it has reduced to a liquid state. So this is nothing but a physical change in a substance. Okay. So in overall, we can say that a change in a shape or a size or a color or a state of a substance is nothing but a physical change of a substance. I hope you understood. Also, in physical change, no new substances are formed. In an example of pressing of paper, is there any new substances formed? No. Therefore, we can say that in physical change, there is no new substances are formed. In a physical process can be a reversible one. For example, if I consider this paper, I am going to fold this paper, right? Now its size has reduced. This is a physical change, right? Now what I am going to do? I am going to unfold this, right? What about the size? The size is as same as before only. So, is this reversible? Yes, it's reversible. So, we can say that a physical change can be a reversible process. In some cases, this physical change cannot be a reversible process. For example, breaking of a glass bottle. After breaking that, we cannot make it again a bottle. Therefore, we can say that in some cases it is irreversible process. Okay. Now let us understand chemical change. In chemical change, one or more substances are formed. For example, burning of a paper. After burning the paper, we get the ashes of the paper. Here, the new substance is formed, that is ash. So, it is nothing but a chemical change. So, we can say that in a chemical change, one or more new substances will form. Other example is rusting of iron. Okay. This chemical process cannot be a reversible process. How? As I said before, burning of a paper. After burning paper, we get the ashes of a paper. From these ashes, can we make paper again? No, we cannot make paper. Therefore, we can say that this chemical process cannot be a reversible process. Right? In addition, with new substances, heat, light, or any other radiation may be given off or absorbed in a chemical process. And also, sound may be produced in chemical change. There can be a smell in chemical change. Okay. There can be a change in color. Okay. And also, gas may be produced in a chemical change. Right. So, what is chemical change? In a chemical change, one or new substances are formed. Okay. This chemical change cannot be a reversible. And also, in addition with new substances, heat, light or any other radiations may be given off or absorbed. Sound may be produced here, and so there will be change in smell may take place. Okay. There can be a change in color also. A gas can be formed. Okay. The materials or substances like aluminium, copper, gold, silver, diamond, graphite, etc. are divided into two types, that is metals and non-metals. So let us see what are metals and non-metals. Here aluminium, copper, iron, gold, silver, etc. are called as metals. Okay. Diamond, graphite, lead, oxygen, carbon, phosphorus, hydrogen, chlorine, iodine, etc. are classified as non-metals. These metals are hard solids, isn't it? Because here iron, copper, aluminium appears as hard, right? Whereas the non-metals are not hard, they are soft. Okay. There is an exception in metals. As I said, metals are hard, but here sodium and mercury are not hard. But here sodium, mercury are not hard solids. In fact, here sodium can be cut with a knife. Sodium is a soft metal, whereas mercury is in liquid state. So these exceptions are very important, not only for your academic purpose but also it will help for competitive exams also, like IAS, KAS, PSI, etc. Any UPSC or KPSC exams, these exception will be important. They may ask you, name a metal which is a soft one. So the answer will be what? Sodium. They may also ask you, name a metal which is in liquid state. So the answer is what? Mercury. Okay. Non-metals are soft in nature. But here also there is an exception. As I said before, diamond is a non-metal. So this is the hardest natural substance in nature. Okay, diamond is a non-metal. It is the hardest natural substance in nature. So there may question arise, name a non-metal which is hardest. So the answer is what? Diamond. Here metals are malleable in nature. What does mean by malleable? It means these metals can be beaten into thin sheets. For example, gold. Gold can be beaten into very thin sheets. So metals are malleable in nature, whereas non-metals are not malleable in nature. Okay, they will be in powder form, or they may be in the gaseous form also. Metals are ductile in nature. What does mean by ductile? Here ductile means metals can be drawn into a wire. Here gold can be drawn into a thin wire and silver can also be drawn into thin wire. In electrical wires, there is copper inside the wire. So this copper is what? Metal. So we can say that metals can be drawn into wires. That is, they are ductile in nature, whereas non-metals are no ductile in nature. Here metals are lustrous in nature. What does mean by lustrous? It means they appear shine. Here silver, gold, etc. they appear shine. Whereas non-metals are dull in nature. But there is an exception. What is the exception? Here diamond and iodine are lustrous in nature. They appear shiny, right? Therefore, there may arise a question. Name a non-metal which is lustrous in nature. That is diamond and iodine. Metals are sonorous in nature. What does mean by sonorous? It means they produce sound. Metals produce sound, whereas non-metals does not produce any sounds. Here metals are good conductors of heat and electricity. Many of you may seen heating water coil like this one, right? Here this coil is made of nichrome and the nichrome is made of nickel and chromium. So from this water will be heated. So we can say that metals are conductors of heat. How the water is heated? It is heated through an electrical cables. It is an electrical cable. Inside this cable there is a copper wire. Through that copper wire electricity is passed. Therefore the water will heat. So we can say that metals conducts heat and electricity. Whereas non-metals are poor conductors of heat and electricity. But there is an exception. Here diamond is a good conductor of heat and also graphite is a good conductor of electricity. So after knowing this, there may arise a confusion between diamond and graphite. That is, which one is a good conductor of heat and which one is a good conductor of electricity. Let me make you simple to remember this. Here we have graphite. At the last alphabet is E. From this E, we can remember as electricity. So, graphite conducts electricity. E means we can remember it as electricity. So, graphite conducts electricity. And the remaining is diamond, that obviously produce heat. Just remember this graphite and the last from this E, electricity. Like this you can remember, right? And also metals reacts with oxygen to produce metal oxides. These metal oxides are basic in nature. Okay, and non-metals are also react with oxygen to produce non-metallic oxides. These non-metallic oxides are acidic in nature. So how to remember this? The metals oxides are in basic in nature and non-metallic oxides are in acidic in nature. Let me tell you a trick. So here metal oxides are there. So from this metal we can take M. We can write M. And after writing that M, we have to put a strike, right? If you see like this, it will appear as B, right? So from B, we can remember as basic, right? From B, we can remember as basic. So metal oxides are basic in nature. Isn't it a simple trick? How this non-metal is remembered? Here we have non-metallic oxide. From this non, we have O. This O can be written as A. So from this A, we can remember as acidic, right? From this A, we can remember as acidics. So from this non-metallic oxide, from O, we can remember as acidic. And from this M, after putting strike, it will become B. So we can remember it as basic, right? So metal oxides are basic in nature, non-metallic oxides are acidic in nature. And also some metals react with water to produce water hydroxides and hydrogen gas. For example, sodium. Sodium reacts with water to produce sodium hydroxide and hydrogen gas. Here, hydro means what? Water, right? So, if any metal reacts with water, this will produce what? Hydroxide. So, from water, it will be what? Hydro. Hydro means what? Water. So, if any metals reacts with water, produce what? Metal hydroxide and hydrogen gas. Like this, we can remember. Generally, these non-metals do not react with water. Metals react with acids and produce metal salts and hydrogen gas, whereas non-metals do not react with acids. Here some metals react with bases also, which will produce hydrogen gas, right? So here metals react with water to produce metal hydroxide and hydrogen gas, and also metals react with acid to produce metal salts and hydrogen gas, and also metals react with bases also and produce hydrogen gas. Thus, more reactive metals displaces less reactive metals. Also in non-metals, more reactive non-metals displaces less reactive non-metals. So let us see this reactivity series. We have the elements as potassium, sodium, lithium, calcium, magnesium, aluminium, zinc, iron, copper, silver and gold. The chemicals symbols are potassium as K, sodium as Na, lithium as Li, calcium as Ca, magnesium as Mg, aluminium as Al, zinc as Zn, iron as Fe, copper as Cu, silver as Ag, gold as Au. The gold is more reactive than silver, and silver is more reactive than copper, and copper is more reactive than iron. So this will be then increasing order of reactivity. So here the most reactive element is potassium, right? So you have to remember this reactivity series. It will help you in 11th standard and 12th standard also. Okay. So how to remember this reactivity series? I will tell you the trick to remember this. Now written a sentence. From this you can remember this reactivity series. The sentence is, please stop like calling me a cute zebra. I like her calling smart guy. Right? What is this? Please stop calling me a cute zebra. I like her calling smart guy. So from this please we have P. P means potassium. Here we have stop. In this stop we have S. S means sodium. Like. In this we have Li. From this Li, lithium. Calling. In this we have Ca. This Ca will be what? Calcium. M, Me. In this Me we have M. M means we can remember as magnesium. Acute. In this A we can remember as aluminium. Zebra. From this Z we can remember zinc. I like her. From I we can remember iron. Calling. In this calling, from this C we can remember as copper. And don't confuse between this calling and this calling. This calling is for first calcium and the last one is for copper. Smart. From this smart we have S. S means silver. Guy. In this G we can remember as gold. Isn't it awesome? Yes. So I hope you understood my today's explanation. And also I have explained some basic concepts of mathematics. The links are given in the description box. Please check out. Thank you.